Hello, ladies and gentlemen, and welcome back to Chapter 16. We are talking about acids and bases, and this is part 2. So far, we have talked about characteristics of acids and bases, but the reality is, what are acids and bases? Now, the reality is it really depends on who you talk to as to what an acid or base is, because there have been different definitions in the past, and different people will apply different definitions depending on their own situation. But some of it does depend on those characteristics we talked about, because some of the definitions of what acids and bases are have changed because there were substances that didn't fit the definitions, but they acted like an acid or a base. Okay, first off, way back in the 1880s, Svante Arrhenius defined an acid as a substance that releases a hydrogen ion in aqueous solutions. Aqueous simply meaning liquid. Okay, so if you put this substance in water, it would release hydrogen. Okay. He then said a base is a substance that releases hydroxide in aqueous solutions. So you take the substance, you put it in water, and OH negative comes off, and you have these ions that are created. An acid releases hydrogen, a base releases hydroxide. There were, however, some limitations in Arrhenius's definition of what it meant to be an acid or base. First off, because it only included solutions that were liquid. It doesn't include gases and solids and things like that, which some of which are. It also doesn't include all of the substances. This is the narrowest definition of what an acid or a base is an Arrhenius acid or base. Okay, and it's really just a definition of an acid or base, but you stick the guy's name with it so that it defines it according to the way he defined it. Now, that definition stayed for a long time. That definition, in fact, stayed until the 1920s, when two different gentlemen, Thomas Lowry and Johann Bronsted, uh, separately but at the same time came up with the same definition of what acids and bases were. Okay, they weren't even in the same country, but they came up with the idea at the same time and defined it the same way. So it became known as a Bronsted-Lowry acid. And they came up with the definition that it's a substance that donates a proton. And when it donates a proton, it's called deprotonation. Okay, D from proton. Okay, now that essentially is what Arrhenius said, because a hydrogen ion, H plus, is a proton. So far, although the wording is different, it ends up being the same thing. So this would include Arrhenius acids. Now, you can have protons donated that are not hydrogen. So it includes other things as well. Now, Bronsted-Lowry base is the opposite of an acid. It's a substance that accepts a proton. Okay, and if it's doing that, that is protonation. It's gaining a proton. Now, this includes more substances than what Arrhenius came up with. Okay, so because of the difference of going from hydrogen and hydroxide to using the transfer of a proton, it gives it a wider range of description. Now, when you use Bronsted-Lowry acids and bases, you have something called conjugate pairs. Conjugate just kind of means that they go together. Okay, now try to follow this. Okay, we have hydrochloric acid. We know it's an acid. Okay, but it is an acid because according to Bronsted-Lowry, that it releases a proton. It does that in the version of, in this case, hydrogen. Okay, and what is left is a Cl, chlorine ion. Now, this is called a conjugate base because if you think of the definition of what a base is, it accepts the protons. Chlorine ions can accept a proton. So you take a substance that it's an acid, you remove the proton, and that creates a base. Okay, so you have an acid and it pairs with a conjugate base. Okay, it's a way of identifying things in the reaction. So at first it's an acid, you take the proton off, it's going to go to the NH3, and then you end up with a base. Okay, at the same time you start out with NH3, which is ammonia, which is basic. It's going to gain the hydrogen proton and it becomes NH4, which has a charge. Now, it accepts the proton, and then this right here has the ability to lose a proton. So it becomes an acid. Okay? So the acid releases a proton, the remains become a base. The base accepts a proton, and the combination becomes an acid. That's what it's talking about with conjugate pairs. Okay, and you should be able to match what goes with what, so you can follow those protons around. Okay, the last gentleman we're going to talk about is somebody you have heard of before, although we haven't talked much about him, and we're not going to. You have Gilbert Lewis. Lewis structures, those electron dot structures, Lewis diagrams. Okay, he came up with his own idea too. A Lewis base is a substance that can donate electrons, not protons. Okay, and you'll notice he did this at the same time as the other guys, but it's different wording. Okay, so the base loses electrons and the acid gains the electrons. Okay, this is the most inclusive description of acids and bases. So we went from Arrhenius, which is very specific and narrow definition. You then went to Bronsted-Lowry, which included more substances, and then you went to the Lewis acid and base, which actually have the broadest description. So with the Lewis description, you actually include pretty much every type of substance that acts like an acid or base. And if you look at the electron dot notation, it shows the description of what's going on. This is the acid. It only has 6 electrons. It wants 2 more. It can survive like this, but it'd like 2 more. So it ends up sharing these 2 with the ammonia, which is a base, and you end up with them combining together, and you have a new substance formed that's neither an acid or a base. Okay, so no conjugate pairs here. Okay, make sure you can distinguish between the different types. If you have questions, make sure you ask. Okay, until next time, be well.